MG headquarters. We're the distributors for high-end audio products. Today we're going to be talking about line drivers. Now, line drivers are something that some people may know, some people may not know. Line drivers were used predominantly back in the day when there were only RCA output head units, and they were typically very low. As time went on, the head units got better and the RCA outputs were getting up to as much as 9 volts. In fact, Rockford had a head unit back in the day that was around about 9.5, balanced output, super clean, no distortion. It's like the holy grail. What's happening today, people are replacing these radios with aftermarket radios for auto Android and CarPlay, etc. Nice touchscreen. The problem is the audio aspect of these things. So they work pretty well as a GUI, they've got nice processing, they give you your mapping, the music can play, etc. The problem is the RCA outputs are unfortunately very, very low. In fact, this particular unit here, we'll show you later, I think it's only about half a volt at best. It isn't distorted, so what people are doing is they're now taking the head unit, they're not using the RCA wires, they're now using the speaker leads, which is great, you get more power, but the problem is you also get distortion. So what happens is you end up then taking in a nice amplifier and a nice DSP or whatever it is, and you're getting this distortion coming out of the head unit's output, which is just a normal chip, unfortunately. And whatever you do, you can level match your amplifiers, you can do whatever you want, you're not going to get away with that. And then you've got to start doing line converters and all these things, and that just adds more noise to the signal. So what we've done is we've set up an experiment here where we're going to show you on a scope, and also we're going to show you the actual output power and what actually happens just on the RCA outputs, and then we're going to show you what it does when you use speakers, and then we're going to show you the solution to this. And this is a phenomenal component. It's manufactured by AudioControl. It's called a Matrix. It's got 6 channels, so you can run front, rear, and sub, and you can individually set the levels so that you can have maximum signal and less noise. And of course, signal to noise ratio is one of the key elements in good sound quality. This unit is designed to fit behind the radio or somewhere close to the radio so that you can line drive the signal as much as possible to the rear of where the amp is. The good thing is you can turn the amplifier gain right down, which means you're driving as much signal. That's why it's called a line driver. This is not a line converter, don't get confused. It's not a high to low converter. It takes low level signals and amplifies them, which is what we're looking to do here. And the key is the closer it is to the radio, like I said, the less potential possibility of getting noise in. Notice here we're running 12.3, 12.4 volts. I'm going to turn this up just a little bit so we can actually get to 13 volts, which is, I would say, the average of what most vehicles would run. So I'm not going to go to 13.4, we'll keep it in the middle so we can give this a fair test. So over here we've got a good little unit, very popular, TT Audio. Nothing wrong with the product in terms of its functionality, but you'll see now if I turn this unit up to full, okay, so there we have it. If you zoom in over here, you'll see it's only 0.5, so it's just a little bit over a half a volt, which is pretty dismal. I mean, if you're going to go and open up your amplifier gain to max that, you're going to have that gain pretty wide open. Most amplifiers work from about 250 volts up to about 4 volts, or at least ours do. And that's a problem because now you're amplifying any potential noise. And most cars have a lot of electronics, and with that electronics, obviously you're going to create some kind of EMF noise, which could be generated into the signal cables, which of course gets part and parcel of the amplified source. If you look at the scope here, you'll see it's pretty clean. There's no distortion present. I'm playing it full. Everything is cozy, okay? Problem is, people find when they turn up the gain, like I said, there's not enough power, and they go, wow, this doesn't sound great. I'm picking up this engine noise, I'm picking up all these other issues. Well, also you'll see on the RTA over here, it's got 1K boosted, which is what we're playing. We're basically playing 1K. And you may ask, why do we use 1K? That's the industry standard. It's the center frequency on the spectrum. Which means at any frequency we could be emulating the same problem, but actually on lower frequencies, generally those preamps in these head units and their RC outputs find it even more difficult to amplify. So I can tell you now, I can almost guarantee if I played 40 Hertz, I'd have even less power, which is a problem. So your bass is going to be compromised, no bass. People are like going, hey, I've got all these great woofers, but what do I do to get bass? So they start putting in the speaker leads. At least we know the head unit's flat, so that's great, it's a flat response. So far we got good audio quality, but we haven't got the power, okay? So what do people do? They go and hook up the speaker leads, which we're going to do right now, and we'll show you the difference in a second. Moved over to the speaker leads. We connected the speaker leads up to the scope. So at volume 44, everything looks quite normal. We're getting 2.4 volts, and everything's great. But as you know, customers always try and push the volume to the max, and music, unfortunately, is never recorded at the same level. The maximum recorded voltage you can get on any format is 0 dB. Anything past that will be clipping, which is essentially what I'm going to show you and demonstrate here. Where the sine wave is no longer a uniform shape. It has a clipped top and bottom, which essentially is heard as distortion. And then of course, distortion creates excessive heat, which can burn speakers, and a whole different subject for another day. But that's something we don't want to have. We don't want distortion. We want to get as pure signal as possible. If I turn up the volume here and you just zoom in over there, you'll see what happens. You'll see it starts clipping quite badly. And in fact, on this scope, we're getting a lot of power. We're getting 4.89 volts, call it, let's say 5 volts. So that's great. We've got a phenomenal amount of voltage, which means it overcomes this problem of signal, and the bass is pumping, but we have this issue. Now I'll go into the equalizer. So of course someone says, I want more treble. So they go and they push the mid-range up, whatever, okay? They do whatever they want to do, and they start playing around with this thing because they're easily available. Hey, look at the distortion now. So you've got more power, but you've got bigger issues. And I mean, there you can see it clipping. If you just zoom in over here, you can see it pretty clear. Nice jack square wave, which is why they call it a square wave, because it represents a square, but it's just distortion, and there's a bunch of it in there. And that's going to create heat. So it's pretty much like the sine wave is on off, which is what an AC signal does. But if you have that on for a long period of time, you're going to end up burning speakers, and it just sounds terrible. So now what we're going to do is solve this problem by saying, well, how do we get the best of both? How do we have that pure signal coming out of that source, but we get to our power, so which means we don't have a loss of energy, and we also don't have the problem with distortion, and still maintain the fadeability as well as control over the subwoofer. So this guy here called the Matrix from AudioControl, it is a 6-channel line driver, like I said, and you can configure this thing to have 1 input, to have 6 outputs, so you could have just 2 inputs and 4 outputs. You can configure it in any way you wish. You can run individual, front, rear, and sub, so you have full fading, full control. Sometimes head units don't have the sub output, so this can create it from here, and you've got your levels, and you can adjust them accordingly. So we'll go and plug this in now, and we'll show you how we can overcome the challenges that we were experiencing earlier. Alright, so here we have the Matrix now hooked up, so we have the RCA out. We're just using one of the inputs at the moment, but like I mentioned, you can run all of these inputs, and these will be duplicated and obviously on front, rear, and sub. So as you can see on the scope, it's showing a very clean signal. There's no distortion present. I'll get it up to the same voltage. If you look on the scope there, I'm getting very, very little signal. So I'm going to get it up to where we were. So volume, I'm going to turn it up to full. Now previously on the speaker leads, as you knew, it used to distort. It's not distorting, it's still clean. I'm going to max the level to where it was, which was 500 millivolts. I'm going to get it as close as I can. So that would be the same as having no line driver. It was about 0.5 some change. I'm going to bring it, there it is, 0.569. It's clean, happy days. It demonstrates on the scope over here, the TPR tells me the voltage, 0.569, which is just over half a volt, and I've got a clean signal. But as we know, that's a problem because we're not going to get our signal to noise ratio right. So let's go and crank this guy up. And this guy has 3 indicator lights, 1 volt, 2 volt, 5 volt, and then maximized, okay? Now the only time you'd ever maximize that light is if you were feeding in a lot more voltage than this end and you exceeded the output circuit of it. Now, as I said earlier, the more voltage we can get from this, the better, which means the gain has been turned right down on the amplifier. I'm going to turn it up and watch what happens. Okay, look at that scope. It's just going to get bigger and bigger and bigger. I'm turning it up and I'm getting to flat out, and it is super clean. If you want to come and look at this one, you can see it's a little bit different resolution. I've got 7.37 volts. The maximized light's not on. I've got the 5 volt indicator on, and I'm getting almost 7.5 volts, which is insane. I mean, that is like unheard of. And the cool thing about this is 72 ohms. I can run probably about 50 amplifiers per channel or per pair of RCAs on this guy, because it's got such an amazing power supply and circuitry. And because the source impedance on this is so low, you can parallel as many amplifiers that you need. So if you're an SPL guy, whatever you want to get a lot of injected voltage, this is the guy you need. Obviously, in most applications, you wouldn't need that. So you can be assured that this voltage will stay the same, irrespective of whether I wire a channel per, a pair of RCAs per channel, or whether I go and split them again and again and again. So there you have it, the Matrix AudioControl Plus, available through Automotive distributors. Yeah, it's a really cool piece, and anyone else who's had the experience of bad audio quality or distortion, there's your magic trick right there. So yeah, Tech Tip Tuesday. We'll see you next week.